welcome you to this very first conference in Singapore, Supercomputing Frontiers, Singapore 2015.
So I'd like to talk to you about what I think is going to be a revolution in the fundamental way that we do calculations on computers.
Built by the National University for Defense Technology. They're the integrators. They went out and they bought parts from Intel Xeon processors and Intel co-processors, put them together.
In the end, I think we're going to need a mixture of technologies. It'll be great when we can dial in basically the number of samples relative to the length, so we can get a output data that's tuned to what we're looking for.
The reduction of the operating voltage of computers to basically realize huge energy saving, but potentially with the risk of increased faults.
Then you say, wait, what about the vector machine? Vector machine, von Neumann derivative. SIMD, von Neumann derivative. MPP, or my favorite, commodity Linux clusters, von Neumann derivatives.
But having that knowledge of your errors, your accuracy, can help us make these trade-offs even when we move data and process data along the way.
So in other words, from generation to generation, we'll make a contract with you that we will improve the thread scalability of the architecture, both runtime and hardware.
Because convergence with big data is our big agenda, but also outlook in the future of how these machines will evolve.
So that got me thinking, totally guilt-laden, on what I could do to contribute to the community in such a way that it would be another big bang that would justify my continued existence in that Hall of Fame, right?